Somewhere in the Milky Way, a star is moving at 5 million miles per hour. That's fast enough to cross the entire United States in less than 3 seconds, fast enough to escape our galaxy entirely. And it's not alone. Astronomers have discovered dozens of these cosmic speedsters, stars moving so fast that our galaxy's gravity can't hold them. They're called hypervelocity stars, and the forces that created them are among the most violent in the universe. But here's what makes this truly unsettling. We've only found the ones that haven't escaped yet. Millions more may already be gone. So what could possibly accelerate a star to these speeds, and what happens to the planets orbiting them? Let's start with the most dramatic scenario. At the center of the Milky Way sits Sagittarius A star, a supermassive black hole with a mass of 4 million suns. Stars orbit this monster in a gravitational dance that usually stays stable. But sometimes, a binary star system, 2 stars orbiting each other, wanders too close. When that happens, the black hole doesn't just pull them in, it tears them apart. In a process called the Hills mechanism, named after the astronomer who predicted it in 1988, the supermassive black hole captures one star while flinging the other outward at extreme velocity. The captured star spirals inward, eventually consumed. The ejected star rockets away from the galactic center like a stone from a cosmic slingshot. The first hypervelocity star was discovered in 2005, traveling away from the Milky Way's core at 1,555 kilometers per second. That's more than 0.5% the speed of light. Scientists traced its trajectory backward and confirmed it originated near Sagittarius A star. The black hole had launched it. But here's where it gets stranger. Not all hypervelocity stars come from the galactic center. A massive study published this year analyzed 214 of the largest runaway stars in the Milky Way. The researchers combined data from the Gaia Space Telescope with detailed spectroscopic measurements. What they found challenged assumptions. Most of these runaway stars weren't ejected by black holes. They were kicked out of dense star clusters through gravitational interactions with other massive stars. Picture a cosmic game of billiards where the balls weigh millions of tons and the collisions happen at hundreds of kilometers per second. One unlucky star gets flung out of the cluster entirely. And there's another mechanism, supernovas. When a massive star in a binary system explodes, the surviving companion doesn't just watch. The explosion delivers a gravitational kick that can send it racing through space at incredible speeds. The researchers found that the fastest spinning runaway stars were likely accelerated this way, their rotation a signature of violent separation from a dying partner. Let that sink in. These stars were once in stable relationships, then their partners exploded, and they've been running ever since. The fastest runaway star discovered so far is designated J0927. It's moving at 5.1 million miles per hour, 2,285 kilometers per second. To put that in perspective, our sun orbits the galactic center at about 500,000 miles per hour. J0927 is moving 10 times faster. At that speed, it will escape the Milky Way entirely. Nothing in our galaxy can stop it. And J0927 isn't unique. 6 new hypervelocity stars were found in a single study, all moving faster than 1,000 kilometers per second. All of them will eventually leave the galaxy. Scientists estimate that more than 10 million stars may have already escaped the Milky Way through these processes. They're out there now, racing through the void between galaxies, never to return. But wait, what happens to the planets? Remember that piece of equipment I mentioned at the beginning? It's not equipment at all, it's a planet. Astronomers recently detected what appears to be a super-Neptune world, a planet larger than Neptune orbiting a hypervelocity star. The star is moving at 1.2 million miles per hour. The planet is being dragged along for the ride. If confirmed, it will be the fastest exoplanet ever discovered. Think about what that means. This planet formed in a normal stellar system somewhere in the Milky Way. Then something violent happened, maybe a close encounter with a black hole, maybe a supernova kick, and its star was launched into intergalactic space. The planet held on. It's still orbiting, but it will never see another star up close again. Scientists believe this isn't rare. Many hypervelocity stars likely carry planetary systems with them. Entire worlds flung into the darkness between galaxies, orbiting stars that will never return home. This raises questions that are genuinely uncomfortable. If hypervelocity stars can carry planets, could they carry life? Imagine a civilization that evolved around one of these runaway stars. One day, their astronomers look up and realize their galaxy is getting smaller. Not because they're dying, because they're leaving. Their star is escaping, taking their entire world with it into the intergalactic void. From their perspective, the universe would look profoundly different. No nearby stars, no neighboring galaxies within reach, just their sun, their planet, and an ocean of emptiness in every direction. We don't know if such civilizations exist, but but we now know the mechanism that could create them. Here's what scientists are still trying to understand. The recent study found that the most massive runaway stars tend to be single. They no longer have companions, but 12 binary systems were also identified, including 3 that contain neutron stars or black holes. These systems survived the ejection process intact. They're racing through the galaxy with exotic partners still in orbit. 3 more candidates may contain black holes that haven't been confirmed yet. If verified, these would be some of the first black holes discovered through the motion of runaway stars, rather than through X-ray emissions or gravitational waves. The trajectories of these stars also tell us something important about our galaxy. By tracing their paths backward, scientists can map the gravitational landscape of the Milky Way, including the distribution of dark matter. Runaway stars become cosmic probes, their extreme velocities sensitive to gravitational influences we can't see directly. And this research is just beginning. Future data releases from the Gaia mission will identify more hypervelocity stars. Improved spectroscopic surveys will reveal their compositions and origins. Some may be traced back to specific star clusters. Others may reveal the presence of intermediate mass black holes larger than stellar remnants but smaller than supermassive ones, hiding in the galactic disk. Every runaway star is a message in a bottle, carrying information about the violent event that created it. So the next time you look at the night sky, remember, not every star you see will stay. Some are already leaving, and millions more have already gone, launched by black holes and supernovas into the space between galaxies, carrying their planets with them into the void. The Milky Way isn't just our home, it's also a launch pad.